Good evening, one and all. I'm Diksha from 360DigiTMG, and I heartily welcome each one of you looking into the live session over here on YouTube. So, here we come with a project presentation on real time price discovery and volume management at e marketplaces. So, we worked on this with the team of NASCOM through Clusters AI and sponsored by 360 and InnoDataTex. This is the project name, the total project name that we have over here, which is real-time price discovery and volume management at e-marketplaces. So the objectives, the general objectives and constraints are being described over here. The objectives of this particular project was to build a machine learning model to discover real-time prices for identifying crops across e-marketplaces and accordingly manage volumes. So we were focusing on the market of Telangana to look into the yield and to predict the market prices in each and every commodity and APMCs, in the sense marketplaces all over Telangana. The objective is to maximize the profits for the cultivators and help them in volume management of crops. The constraints of this project was business constraints, what we call as. They are to minimize the problem in increasing crop productivity by altering the cultivators about the predicted productions amount. So we made use of the general CRISP DM methodology, where it starts with the business understanding, then the data understanding, we have data preparation, modeling, evaluation, and deployment. And definitely it was, we were working on a government-based project. So the data that we have scrapped was all from the government portal itself. So this is a general pipeline that I would like to discuss about it. So we had the raw data from the government of Telangana, and we have built an SQL database on this where we could connect it with the IDE, I mean to say integrated development environment with Jupyter. Also, there were data readings that happened over there. Also, we worked on EDA, and EDA was with respect to Tableau that we have done for initial type of explorations on the data. And then we went for pre-processing, cleansing our data and feature selections. Then coming to your, we had a cleansed and a structured type of data, and then moved into data modeling, then evaluating, and then into deployment. So the deployment part, it includes an web application, an mobile application, an Android application that we had. And the basic idea was to help the farmers to predict the prices so that volume management could be done in a better way. So this is a general project. This is our general project pipeline that we have worked on. The contents that we have in the specific project includes introduction, the data pre-processing, analysis, and conclusion. So I'll be discussing about the aim and the business problem that we have dealt on. Coming to the aim part. The agriculture market, we know that it cannot just be explained by the simple principles of supply and demand. Rather, it is an interplay of many variables that ideally should be used in price discovery of crops. The report that we have over here, it provides a general description of price determination for a specific commodity that was given as a use case for us. The use cases, it included 3 crops. Okay, so it was maize, it was groundnut, and it was Bengal gram. So we focused on this. In addition, an understanding of interplay of market forces over the contribution to flexibility in making policies for what may be short-term market phenomena, that was also our major aim to focus on. So post-harvesters, nothing but farmers, they generally rely on the local prices set at the mandis and marketplaces to sell their crops. It has been witnessed that using historical and real-time data, machine learning models could be built to predict real-time prices and also help manage crop volume. This was the major aim of our project that we are working on. So our aim is to build a model and easy to use application on real-time price discovery and volume management at e-marketplaces in the agriculture sector. Hence, we present you the data on the agriculture around the Telangana from 2016 to 2020. Because of COVID, there was a loss of data collection that happened. So we could not collect the 2021 data. We couldn't find the data. So yes, we have worked on 2021 and 2020. We have the records of it in a bundle. However, of the year 2021, we have the data till February. And the key objective is to understand the forecasting trend in APMCs. With APMCs, I mean to say it is agricultural product market community. In short, it's mandis. So what are we focusing on? We are focusing on the minimum price, the maximum price, and the average price. In the sense, the model price. And the quantity arrival data for different commodities in Telangana. The future scope. Coming to the future scope, it's nothing but with respect to the IoT concept that we have. In short, it's nothing but smart farming along with IoT. Smart farming is a high-tech and effective system of doing agriculture and growing food in a sustainable way. It is an application of implementing connected devices and innovative technologies together into agriculture. Smart farming majorly depends on IoT, thus eliminating the need of physical work of farmers and growers and thus increasing the productivity in every possible manner. It's been a long since sensors were introduced into agricultural operations. But the problem with the traditional approach of utilizing sensors technology was that we were not able to get the live data from the sensors. The sensors used to log the data into their attached memory and later we were able to use it. With the introduction of industrial IoT in agriculture, far more advanced sensors are being utilized. The sensors are now connected to cloud via cellular satellite network, which lets us to know the real-time data from the sensors and making decisions effectively. The application of IoT in the agriculture industry has helped the farmers to monitor the water tank levels in real time. Also, when it comes to agriculture, it helps in tracing the quantity that is being importing and the quantity that is being exporting. So volume management becomes easier when we integrate it to IoT. So this is a future scope that we have. Along with that, if at all we get an access to if at all there's a proposal to the government, we can actually have the database of the commodities that we are looking into, and we can help them in predicting the volume management, the volume for the future outcomes, for the future days. And that may be easier for the farmers to work in a more easier way. Coming to the technical stack, we worked on the SQL, the database, Flask for deployment, Python for development, MIT App Inventor for APK file, the Android application, Jupyter, which is an IDE that we have, just like our Python IDE. So, and Tableau for data visualization, Pickle for compressing our data for deployment purpose. Let me discuss something about the data collection that we have done. So the data that we have, it's related to the government portal and it focuses majorly on groundnut, Bengal and maize. We have collected our data from tsmarketing.in, which is an official website for giving us the data about APMCs, the commodities data. Later, we have made a connection to MySQL database using our Python scripting, such that it can capture the data, store it in the database, so that we can make use of the data for further development. The data was available from 2012 to 2021, but as 2012 to 2015, there were few new entries of the data. We were not, the whole type of data was not available to us. Because of, we were focusing on Telangana's data, so that's why we could not get the data from 2012 to 15 because of other constraints that we have, political constraints. So definitely we started capturing the data of 2012 to 2020, and these were considered. And there are all total 75 market names that we have focused on. Here are a few of them. I shall pick out few for you. One is Mehboob Nagar, one is Vanapati town, Warangal, we have Bodhan, we have Adilabad, we have Khanapur, Nirmal. These were few of the APMCs that we have focused on. The data dictionary includes the date. This was a time series type of data that we were working on. So it has the date, it has the APMC names, nothing but the market names that we have. And then the crops. We had the crop names. Crop in the sense we were focusing on 3 varieties of crops. One was our maize, one was Bengal gram, and the other one groundnut is what we were focusing on. Apart from that, we have volume data, which was in quintals. Apart from that, we had maximum, minimum, and model type of pricing data, which was available for us. So the commodities that we focused on, like I said, it was groundnut, maize, and Bengal gram. To the further categorization of each specific commodity, groundnut was categorized into two. We had 2 varieties of groundnut that we had in our data set. One was with respect to the pods common, and one was with respect to pods wet. So that pods in the sense that's nothing but that comes in a bag, a wet bag. So that is how the varieties were segregated, and we have the data of that. Apart from that, we have maize common, maize hybrid old, maize hybrid new kind of data. That was also a part of it. And we had Bengal gram, the common Bengal gram, and there was no hybrid or any other varieties out of it. So these were the main focus of commodities that we were working on. Later, coming to the data reading part. So we have channelized the raw data to MySQL, where the data is stored. Doing so, it helps us in future utilization of the data. Later, we made MySQL connection to our Python editor for implementation and to import our data. However, the data used for EDA in Tableau includes the direct raw data for initial explanation of the data. So our data preprocessing also includes transformation using label encoding. It includes removal of any values. It includes transformation using min-max scalar to normalize our data. Also removal of outliers that we had. Coming to removal of any values that we have in our data, what happened is that when we collected the data, there were few missed entry of values that we had. However, they were minimal in terms of the whole ratio of the population that we had. So we focused on, instead of doing any other technique of imputation, we thought of removing them because they had a very minute contribution for changing our data. So yes, we focused on removing it. So there were around 0 to 0.14% of missing values that we saw. And coming to outliers, there were 0.05% of outliers. And we also got a major insight of having maize common, that specific variety of crop, to be the highest production over all other crops that we have. So maize can be one of the reason for building the economy in Telangana that we have out of all the 3 varieties or commodities that were selected. So coming to analysis, the EDA part that we have, so there was we have a dashboard for you to look into the concept over here. So we see that, like I said, maize was the highest one, and it has the volume quantity of around 51,50,648. So this similar way, we have lots and lots of visualizations that we have taken up. We had the APNCs versus the month of the data. The whole data we can scroll and we can see from 2016 to 2020, what are the data that have been manipulated or they have fluctuated, and what specific month we have highest production of a specific crop. Those kind of information we could get from the EDA from our dashboard, which is done by using Tableau. Also looking into the specific APMCs that we have, which was 75 in number, we could also see the volume management over here. The numeric values that you are seeing over here, these are nothing but the volumes of each specific crop that we have. So the blue color ones are maize common that we see. Let's consider Warangal. So the blue color ones that we see, it's maize. The yellow color one that you are looking into, these were nothing but groundnuts that we were focusing on. The pink color one, this one, is nothing but Bengal gram that we were looking into. The little darker pink color one that we have over here is nothing but maize hybrid, new hybrid maize that we have over here. Okay, I'm just roughly writing it. Please ignore my handwriting. Apart from that, we had other colors of shaded blue color and green color. However, we do not find it in Warangal. So that is how we could get the data of each specific APMCs and their commodity values. So this was a generic EDA dashboard that we have built on. Apart from that, we had the map view also. We were focusing on each specific commodity that is being produced by a specific APMC of Telangana. APMC is different from district sprints. Many of us do get confused about it. And APMCs are marketplaces. And that is why you'll find few emptiness present in the data. These are nothing but the marketplaces that we have all over Telangana. And it would give us the details about commodity, the state, the maximum pricing value, the minimum pricing value, the model, and volume. And everything is in summation. So this is a map view of Telangana with its crop production and its volume in quintals. Coming to forecasting. Here we are focusing on forecasting of the prices. So we have a minimum price, maximum price, and the model price. So coming to the forecasting of minimum price with their volume in each month of the date, we could find that there is decrement happening from what we had it in 2017. Similarly, when it comes to maximum prices over here, we again found that there was high production of maximum price in 2017 rather than now. So these are being slowly standardized. And this has a far more impact than what was in 2017. Altogether, we see that 2017 has the highest values in all the three containers that we have for minimum, for maximum, and as well as for model. So this is a visualization on forecasting on minimum, maximum, and model price that we were dealing with. Next, we could focus on the forecasting results for Bengal gram and its prices. We focused on forecasting results on groundnut pods, which were common with its price. This is how we were working on. And these are few values. We worked on maximum, minimum, and model all together, three of them, for each specific commodity that we were selecting. So this is how our graphical representation looked like, and we were predicting it for the next few months in 2020. So we could, for example, let's consider commodity. So we were in place of groundnut pods. So we are making use of the forecast indicator to estimate the value. So in the month of Feb 2022, we see that the minimum price would be somewhere around, the summation value would be somewhere around 8,88,238, which is far less than what we have in here, which was 17,10,640. So yes, this is a challenging part for our farmers that we have in Telangana. And yes, there's a major impact from the year 2017 to 2020 over here. And the volume in quintals also we could see, which is 152,898. This is the total value of volume in quintals for the groundnut pods in common. Right after it, when it comes to groundnut pods wet, we see that there's no forecasting happening over here because they have been there's no production of groundnut pods after a certain point of time. So that is why there's no forecasting that we see for groundnut pods over here. Next, we have the maize common values, and it has major inferences to speak about. Coming to maize common, for the year of November 2021 that you can see, the model value that we have seen, the model price value that we are seeing is somewhere around 2,77,277, which is again very less than, I mean not so very, but yes, it's less than 7,54,351. The volume in quintals were also being, I mean, we have it over here. The count is 1,31,741. The tableau could give us more good inferences rather than, I mean, more good inferences, initial inferences over here. So we also, yes, I forgot to speak about this maize hybrid and maize old. If you look into this, the maize old hybrid also does not have any forecasting. Now that it's an old type of hybrid that was being used, it's not being continued for, I mean, that kind of hybridness is not now being continued. And the new kind of hybridness is what is being applied. And we see a stationary kind of data that is being generated for all three, for minimum price, for maximum price, and for model price, all three together. So this is how the major, I mean, the what do you say? The initial type of data visualization were done in Tableau. And with this, we could understand that we need some mature information about this. However, Tableau is not so matured with forecasting and forecasting models. So we went into model building, and coming to model building part, my friend Alamelu would be discussing about it. And we have a good number of information so after we applied our machine learning algorithms, AI algorithms from the data. Thank you. Alamelu, please take over from here.
Thank you, Diksha. Good evening, everyone. So as Diksha has already summarized about how we've started the project, I'll continue about how we went about building the model. So as you can see, the data that Diksha has told, the kind of data that we collected, we had the AMC, then we had the crop, and then the minimum maximum values for the crop, as well as the volume, crop volume, and the model value. Diksha, can you please go to the next slide? Yeah, so based on the analysis that we have done on Tableau, so we couldn't go in for any of the traditional forecasting techniques to actually predict the price. So we tried a lot of machine learning models like random forest, and we even tried regression. But ultimately, it was deep learning LSTM, which helped us to get a really good model. So what exactly happened was, one thing was that it was a multivariate data, so we couldn't use any traditional forecasting technique. And another thing was we had like 5 years of data. So from the 5 years from 2016 to 2020, we have split the data in such a way that 3 years of data, we took it as training data, that is 2016, 17, and 18. And 2019 data, we have taken it as validation data. And 2020 data, we have taken it as the test data finally. So LSTM, as the name suggests, it is long short-term memory. So it is inbuilt to actually learn from historical data. And we didn't exactly have a time series kind of data, though we had it for several dates over the years. And for the same date, we had like a lot of entries. For the same date, we had a lot of entries for different market commodities and for different APMCs. So we had to go in for some model which would actually be able to learn how how the prices are evolving over time. So LSTM was why we went in for LSTM for this reason. And Diksha, can you go to the next slide, please? Yeah. So it was real-time price discovery, and LSTM, as the name suggests, as I already said, it's a long short-term memory. So as Diksha showed in the data dictionary, we had APMC, which was the market name. Then we had crop, and then we had the maximum and minimum value and the model. So we didn't need to consider the volume for predicting the price, because based on the price, then we have to predict the volume accordingly. So as Diksha showed already that we used the transformation, and then we used min-max scaler. So these were categorical values, the APMC and the crop. So we have done label encoding for those two. APMC, there were like 75 values. So we have done label encoding for that. And the crops also, though we did it only for 3 crops, which is Bengal gram, maize, and groundnut, because there were varieties, sub-varieties in each of them. we had totally like 6 values possible for crops also. So after we did label encoding, and then we had to do min-max scaler for the entire input features, which was these 4 columns, basically the APMC, the crop, and the minimum value and the maximum value. So after doing all this, ultimately when we tried LSTM, 2 hidden layers, 20 neurons and 15 neurons each, we got a very good accuracy with the trained data. The trained data we got 97%, and the validation data we got 93%. Diksha, can you go to the next slide? Yeah. So validation data, we got 93%. And finally, for the evaluation data, which is the test data, the 2020 data, it was 96%, which was really good. So even the challenge was that with the 2020 data, we had to get a plus or minus 10% accuracy. So the model, LSTM model, as you can see, it gave us very, very good results. And then what we have done is we have deployed this using a Flask application and predicted the price. So we had the 2021 data, we had around 2 months of data for 2021. And we have deployed the model in Flask, and we have input the values from the 2021 data, and we have seen the accuracy, which was very, very good. So as the farmers need to use it in e-marketplaces, we thought of giving them a mobile application. So the mobile application, they have to just input these values, the AMC name, the crop, the minimum, and the maximum price. So the AMC name and crop will be drop downs so that they can just select it. And the min and max values, they will have an idea about it because they have been in the market for so many years. Once they give these 4 inputs into the mobile application, it will connect to the Flask application that we have deployed, and it will predict the price and show it to the farmer. So we have done the mobile application using MIT App Inventor. So MIT App Inventor, so this is how the preview of the mobile application looks. So this is what we have done. So as you can see, the AMC name is there, and then there is the crop, and then the min value and the max value. So once the farmer inputs these 4 values, this MIT App Inventor, it has capability to connect to the Flask application in the backend, and we deployed the model, and we were able to get back the price. So based on the price that it is predicting, he can do the volume management accordingly, the farmer. So this is what we have done with the model building. Yeah, so finally, later we can even add on to this, like using the mobile application, he can get alerts for the month that this is the particular price which can be followed for this month, because some of these are seasonal crops. So the price varies according to the season and everything. So that is later what we can kind of enhance. That's what we thought. So thank you very much. So this is what we have done with the project.
Thank you, Alamilu. So yes, friends, whoever are watching us, so yield prediction or price production, it's one of the most important and popular topics in precision agriculture. And it defines yield mapping and estimation, matching of crop supply with demand, and crop management too. And this was our approach to NASCOM and Telangana AIM team for the hackathon of real-time price discovery using e-learning, for e-marketplaces. Thank you, one and all.